Good afternoon, everybody. Thank you for coming to part 3 of the Studio Survey webinar. With me this afternoon is the mining engineer dialing in from Morocco, Haja Rahabat, and I am Kalumba Wale. So we're going to go through the last 2 aspects of the Studio Survey demonstration that we've been looking at for the last 3 weeks. So this is to take care of the final portion of the end of month. So first things first, what we're going to do is quickly recap the database setup, and then we'll process the stockpiles. After that, we're going to run the blast volume calculation. After which, if you have questions, please feel free to ask them. So there we go. So essentially, at the end of this, we'll have a video available of this recording. Like I said earlier, if you have questions, feel free to type them in the tab below. And then also feel free to register for the sessions that are currently being held and are available to you. The first we're going to look at, as stated earlier, is how you're going to create your stockpile calculations, your volume, your reports, and all of this is done essentially by setting it up and then running the tool once, and you get all of these reports generated for you. So you have your PDF plot, which has each stockpile name assigned to each stockpile, and then the volumes that are labeled sequentially. So in this case, this is the report that we'll be generating, so we'll be getting into these details. We'll also have the Excel print of the stockpile report that we're going to do. In addition to this data set, what you're going to generate is a series of solids that you can then use for your audit compliance. The other report that we're going to do will be our blast volume calculation. You'll be able to see the PDF plot, the solid that will be generated. We'll do a bit of, we'll deliberately create some complication that you can see how the blast volume calculator manages it. And then we'll also take a look at how this report goes. So like I said, for those of you that are just joining us, feel free to type questions into your question bar that's on your user interface. And here we go. So in the first webinar, we took care of how to set up a project. So I'll just very quickly do that again. So we go new project. And in there, give it a name. We'll call this webinar 3. I have another webinar 3, but oops, webinar 3. Next, finish. And we've successfully created a project called webinar 3. So on the side, we've got the sheets, the project files, and the project data bar that shows all the files and the layers that you can switch on and switch off. For example, I can switch off the grid, and that's what you see when you switch off the grid. Okay, we can pin that or leave it unpinned. It will pop up whenever we need it. So to make things convenient, I started off by preparing a folder that contains the various data sets that we need in the creation of our project this afternoon. So I'm going to load the survey strings for a stockpile first. So in this case, I'm just going to drag and drop. Let's go to our 3D window. So as you can see, this is a messy survey. So we're going to clean it up using the string tools that are available to us, and then close these strings. And then after we close them, we're going to set them up in such a way that you'll be able to run your report. So first things first, we're going to, let's zoom in, let's break that specific string over there, break string. You type BS or you go to the edit tab and click the break button. So you have several different versions of how to break that. So we'll just break it. You click there and you click there. So we've broken that, we're deleting that. So you can see as the surveyor was picking up this data set, he either moved from this dump here and then crossed over and surveyed that dump. And when he did that, he kept the code the same. So when Studio Survey imported the strings, it took that as the same data set and did not disconnect it. The next thing we're going to do is close the strings that we need to close. So to do that, we know there's a couple of strings. There's a couple of strings that shouldn't be closed, like the ones at the tops of these stockpiles. So we can hold down the control key and select the ones that we need to close, like that one, that one, that one. Okay, this is just for both of them. And that one, and type CLO. Or you could go over to your editing tab and click close strings. I prefer to type the commands, but a lot of people would rather do it differently. So this one we can close, but you can see that this is unrealistic. This was a really shoddy survey, so we can just insert a few points based on experience. Just move it out a bit so that we know that the boundary we're getting is where it's supposed to be. Before you say anything, no, we are not supposed to do that. You're supposed to survey everything properly. Go pick up every single point around your stockpile, make sure that you've got yourself a decent data set and you're good to go. So that needs to be closed as well. So for this one, what we're going to do is make use of the string command, which we go to edit, click new string, and we can activate the auto node, or we can click using the left mouse click, the right mouse button to connect the points that have been surveyed. So here I'm using my right mouse button to connect these two, simply because there's this data set nearby, or I can toggle with the rapid digitizer by either typing RAP and switch that on so that it digitizes, or I can simply switch on my auto node. So in this case, I'm going to use the auto node and new string and click to whatever is closest. Now, seeing as that's not what we want, we can undo this properly. New string, snap to that point, snap to that point. So this is potentially something that you would be doing if you were cleaning up a survey done by someone that wasn't paying attention to how they downloaded the data set or did something incorrectly. So RAP switches on my rapid digitizer, and when I click over there, same string, okay, let's go. Let's just finish that up. Close that string. So we now have ourselves a series of closed strings that define the basis of our stockpiles. I thought we closed these. Now this data set is exactly the same as the tops. And then the other thing that you would have prior to starting off with this stockpile survey is you'd have yourself a topography on which these dumps have been created. So in this case, as you can see from the nature of the work that's been done, that wasn't created. So we're going to have to get creative, and we'll use all of these bases to build a topography. So what we're going to do now is select the toes of these stockpiles, toes, 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 photos. Right click and save the selected strings. So the selected strings we have saved, we'll just chuck them into this. We'll have two uses for this file. So for now, we'll just save the base file. And if we go to our Sheets tab, you can switch off the strings that we've got already, and then load the one that we've just created. So that's our basis file, and we're going to load that. We say OK. And what you see here is the bases that we have available. Now, I did promise at the beginning of this webinar that we're going to do a rerun of adding datasets to the database. So in this case, what we have here are PIT bases. Oh, sorry, stockpile bases. But we're not ready to add them yet because the report that we have that we need to create should have a name for each individual stockpile. But what we are going to do, though, that we are going to add to the database is the topography on which these stockpiles are sitting. And we will simply combine each of these strings to form that topography. So we can go plan view, which is not necessary. And then when we go home, we have not yet set up a database for this. So if you missed the first webinar, you can always go back and view the video. But what we are going to do is set this up very, very quickly by going home and clicking settings. So what you're going to have here is where you need to put a directory for your webinar, for your dataset, for your database. So in this case, we're going to our database, and this is webinar 3 without the underscore. And then we create a subfolder in that directory, and we initialize. So once you get that notification, you know that you have successfully initialized the database in that folder. That's webinar underscore DB. Now this here is called webinar for the sake of this exercise. You can name this after your pit, after your stockpiles, after your mine, depending on how big your project is or how many data sets you want to manage. That's entirely up to you. And then under pit, you can go ahead and push in any value you want. So the pit that we're dealing with this afternoon, we're going to call that pit Mona Lisa. It's named after the mining engineer that designed it. And then under the areas, we can leave that as area 1 because this pit will not have any sub areas. So we're going to go ahead and push in some bench definitions. So we'll start with maybe say 1070. And we'll maybe plan for 12 benches and click add. And then that will put in the bench definitions that we need for our pit. And you say, okay. Before I click OK, I think it's worth mentioning that the benches file that you're creating by doing this is exactly the same as the benches file that's created in Studio OP. So if your design team has already defined benches, you can simply drag the benches file folder from Studio OP into the location where this is being pulled from, which you can see from the earlier videos. So once we've done this, we've set up our bench definitions, we can say, okay. And then under ROMs, so like the case that we have now, you could have any number of run-of-mine stockpiles. So under this list, you can have your tailings dams, your low-grade stockpiles, your high-grade stockpiles, your concentrate. It's entirely up to you. So for the sake of this example, we're only going to look at one area, and that's the area that we're going to put in. So we're going to call this ore stockpiles. Or stocks. Like I said earlier, this is entirely up to you. And then we'll add a couple of surveyors to this. I'm going to add myself by clicking rename or double clicking the name. So I can click rename and push my name in, or I can double click and I'll have the ability to edit that. So I'll put in Her Royal Highness and say okay. So we've got 2 surveyors working on this project, and we've got them in this database setup. So everything that we've created an area for, a pit for, a ROM for, has a folder that has been created in the database directory. So for the sake of time, I will not go back through those because we've already done that in the first webinar. We'll make the video available to you. Maybe I can ask Haja. Maybe we could just paste that link into the dialogue, into the discussion dialogue at the bottom, so that everyone has access to those videos.
Definitely.
So now that we've got a database set up, we can then go ahead and create a DTM by typing MD or going over to surfaces and clicking MD. So once we do that, this dialog box comes up. So to make our life easy, I like to put names that will remind me, especially when I've got a lot of DTMs loaded in the data set, what that file is. So when I'm loading it up, it's very easy for me to identify the source and go. But in this case, we only have the one data set that will be created, and we're good to go. So you don't need to use boundary strings. We'll definitely use boundary strings later on. We don't want boundary strings, so we say finish. Oops, sorry. What are we using? We're using the basis file to create the DTM. So we now have ourselves a base or a tuple formed by the toes of the stock bars. So to anyone that's in attendance right now that's thinking this is the standard practice for surveyors, it is not. The practice is we would need to have a tuple of the area before any dumping takes place. And then once that is available, that's what we load into the database. Then you're going to start dumping your stockpiles in these locations or wherever, as long as it has been surveyed before your dumping starts. So this would represent a situation where the dumping has not happened and the surveyors don't have a choice but to use the toes as the bottom. So once we've got that, we go to our home tab and click add to database. So once we get here, we select the pit and the ROMs that this is going for. And in this case, the more important thing is the ROM for which this dataset belongs. And then the surveyor that did this, since I did this surface, I'm going to take responsibility. What type of data am I adding to the database? What I'm adding is a ROM base surface, a ROM base surface. That is where the stockpiles are sitting. So the scope runs across either the current ROM or global. So the difference between the two, if I have a huge topographical map or a huge topo that covers the entire mine license or the entire concession area, that is what I will then say that file is. So in this case, we know that we've done it specifically for this small cluster of stockpiles. So we go ahead and say, nope, the scope of this surface that we're uploading only applies to the current ROM, and the source of this data set is the topo. So we add that to the database, and we're good to go. Okay. So the next thing that we're going to create in terms of wireframes, we can switch off that topo by checking or unchecking this box. So the next thing that we're going to do is create DTMs of the individual stockpiles. So we go ROM strings, we bring those back in and go surfaces, DTMs. Okay, so you'll forgive me, I've got 2 screens, so this is popping up on my other screen. So just in case you're wondering, hey, why didn't that happen? It did happen on the other screen. So in this case, we are going to use boundary strings. So when we say next, it tells us what do we want to use to create our digital terrain model. So we want to use that dataset to create our DTM, and you can also use the basis. It's the same dataset, it just makes it more consistent. So we go next, Then you're going to select the boundary strings that you're going to use to create each of these heaps. So we select our basis file. So if you remember, our basis file consists of these bases over here. So that's what we're going to use as our boundary strings. So when we click finish, the DTM that's created is constrained to those boundaries that we had. So we know that this DTM, this new one, is called new DTM. So we're just going to go ahead and add this to the database as well. So in this case, we're going to say Hajar did this because it's a nice clean data set and she's very, very careful. What kind of data are we loading to the database? What we are loading are the actual stockpile surfaces. I know I've skipped boundaries because there's one more thing that we need to do to them before we can actually add them to the database. So we're going to go ahead and add the stockpile surfaces. Scope, the meaning remains the same. The data source. The data source is the new DTM. Very important. So we add that to the database. Task completed successfully. And finally, we now need to deal with our stockpile boundaries. Now, the one thing that we need to do for these stockpile boundaries is actually assign whatever the names of the individual stockpiles is. So we can come back here to the data bar and then add a column. So what I mean by adding a column, let's just go to the project files first. Let's open the strings and it's open on my other screen again. So this is the data set that we're looking at, represented numerically. These strings over here consist of this data over here. And these are the XYZs of the respective vertices. And then you've got the point numbers that you have, and then you've got all of these other things that define various other things. So you've got the surveyor that did the survey that was imported, the job name that is imported from the GPS, the instrument name of the GPS, the instrument number, the serial number. This is entirely up to you in terms of how you configure. But what we're going to do now is add a column to this data set. So to do that, we go ahead and go data and add a column. We'll type STK name. The type of data set that we're going to the type of name is going to be an alphanumeric because, well, this is actually depending on you, the user. First of all, if your stockpiles are numbered 1, 2, 3, 4, 5, you can leave it as numeric, that's fine. But if you've got Bravo 1, Charlie 2, you can then go ahead and put it at alphanumeric. And then the default value, you can leave it absent. And then you say, okay. So if I bring up that tab again where we open the project file and open the basis file, at the very end, oops, one thing we forgot to do was actually save this file the moment we did this. So we go to basis, right click and click save. So now that we've saved it, when we open that file, you're going to see that column that we added to this data set come in. So what this does is it gives us the opportunity to add a stockpile name to each and every one of these strings. So in order to do that, you go to your edit tab and you edit the attributes because each column is represented as an attribute. So we go to stock name, we select the string that we're dealing with, stock name, and we can call that anything we want. So we're just going to go alpha, apply, select the next one, which will be blank, stock name over there. beta, apply, go over to the next one, select, stock name, Charlie, we apply, we go over to the next one, and so on. So what you notice is when you go back, you're going to see the individual stockpile names that we've got for these written to the strings. So we've done Alpha, Charlie, Alpha, Bravo, Charlie, Beta, Alpha, Bravo, Charlie, A, B, C, D, Delta. Okay, cool. I forgot my alphabet for a moment there. So that's Delta, A, B, C, D, E. So apply that. Then we go to the next one. E is Echo. See, now I have to sing my alphabet to get this sequence right. Apply. F is Foxtrot. Now, this is entirely up to you how you name these things. I just chose to do this because I don't want to forget my phonetic spelling. So go ahead, apply F, and then G finally is Golf. Stock name is Golf. So we apply. So since Check is spelled C-H-E-C-K, we take a quick look at our data set and we can see, there's something that we missed there. That one is supposed to be Alpha. Apply and okay. Did that one right through? Okay, so that one's okay. That one's okay. The only reason we're checking this is because sometimes you may have skipped over to the next string like I did for the first one, and I'd forgotten to click apply. So it's very, very important that you ensure that you check what you're doing. So now that all of these stockpile names have been written to the strings, you can then say okay, and that closes that window over there. And then you're ready to add that to the data set, to the database. So we go home, add to database. What are we adding? We are adding the stockpile boundaries. So Studio Survey is immediately going to look for the strings, and we know that the string that we want to add as the stockpile boundaries is the basis one. And we go ahead and add that to the database. And we're good. So it might so happen that your mine does not change the location of these respective stockpiles. So meaning this tedious process that we've just gone through of naming each individual one, you're just going to do that once. So situations where that happens, if maybe the first stockpile is a high grade one, that one's a low grade one, and they dump consistently on those, maybe the only thing that you're going to do is edit the shape of the boundary, and you've got many, many tools. So maybe you want to change that by inserting a line or something. Oops, I forgot that that one was selected. So if you've got, say, that one and you want to change the shape of that, say you've got a bit more material, you can insert a line and you can change the shape, or you can move a point by typing MPO and move that to take care of any material that has been added. So that will work as your boundary. So let's just undo that. So at this point, you're ready to run your calculation. So we just go to reports, we go to ROM, and these are the only data sets that we've added. So if you had a ROM stockpile surface that you had inserted earlier, that would appear on this dropdown. And if you're like me, you're a bit paranoid and you want to make sure, hey, what surface was done on the 21st of May? You can take a look by, it's opening on my other screen. You can take a look by checking out using your googly eye, and that will open up. And then you say, yes, that's the one that I'm looking at. And then your base surface, okay, Am I sure that this is the one? You can go ahead with your googly eye. This one has been a bit more merciful. It's opened on the correct screen. So that's the correct
adjust it
surface.
a little bit?
And
Can you adjust it a little bit?
oh yeah,
Because we see it's too big.
I can, sure thing.
Yes.
Okay, so there we go. So this is your quick visual check on which data set you're loading into the database, or which you're loading into your calculation, and that will be your stockpile boundary. So in this case, we're happy that this is the very same data set that we want to work with. So we just go ahead and click calculate. So like we did in the other examples, if you've got a lot more areas to work with, you can simply add this to the batch process and leave it, and then go ahead and set your other area up and add that to the batch process. And when you run your batch process, it will then run all of those calculations while you're doing something else. So we click calculate. And our task is successful. So with our googly eye, we can take a quick gander at our results. So in this case, the PDF has opened up on my other screen. So that's the PDF that we've created at 14:31 on this date. As you can see, it's still the exact same time on my monitor right now. So this is the report that we have created with the respective stockpile names that are assigned. And then we've got the alpha pit with that volume, the beta pit with that volume, the Charlie pit with that volume, and so on and so forth. So Hajar, since you did this job, you have to sign off for this and submit it for approval. The other
Yes, sir.
thing that we the other thing that we do get is this table that is the raw data, which is where that PDF drew its info from. So that relates all of these data sets to with respect to the string that it's written on, and the boundary strings, and so on. So all of this information is available to you, and you can see it's got a crazy number of decimal places, which every single surveyor knows, even to 0.1 in terms of volume is okay. The other thing that you do get out of this are your stockpile solids. So these are the volumes that you have created, and you can see that these have been closed off at the bottom for you because you've defined the boundary string and you defined the tuple on which these are resting. So I'm just checking if we've got questions here. We do not have any questions, so I'll move on. So the next thing that you can do at this point is go ahead and just publish your report. So when you click publish, we're not doing the end of month, we're doing the ROM, we're not doing a compliance to plan or compliance to design, and we're not yet doing a blast volume calculation. So in this case, there's only one report. So if you had a series of stockpile reports below this, Studio Survey will save you the hassle of selecting the most recent date and just give you what's most recent. So you go ahead and click publish. You can take a look at it if you want. We've already done that. Publish. So task is completed successfully. So once you've done your publication, your googly eye, and again, the Excel spreadsheet has opened on my other screen. So there you go. Your stockpile volumes, that is the report that you will be seeing every single time you run the stockpiles in that manner. So in as far as the volume calculations for stockpiles is concerned, this is the process. Okay, so if you have questions, please just type them into your question site. I've seen that someone's commenting about a lag. Hajar, do you have the same lag where what I'm
No,
pointing at? Okay,
it have
cool.
been resolved.
All right, excellent. So there we go. That is how you generate a stockpile report without having to copy a volume from individual solids and pasting it. Also, as you saw, we've got the plots already done for you, so you don't really need to go back and start doing this and pasting numbers, the inconvenient stuff that we generally don't like. So all of that is taken care of for you by Studio Survey. So we're moving on to the blast volume calculator. Let me just close this up, close the report, and close that. And I'm going to unload my data set, unload data. We can unload everything at this point. Select all and unload. So with regards to the blast volume calculator, as a surveyor, you're going to go out in the field and do a pickup. Ooh, that's horrible to look at. Let me just change the attribute so that that's a bit more visible. We have loaded some color points. So let's just change the symbols to something more visible. Fixed, and where's our color? We can change the color to something that you can see easily against that backdrop. Let's have them bright. No, let's have them red. Okay. There's an apply button that I couldn't see on this screen. Oh, snap. The size is a bit too small. So let's just go back again. Haja, can you see them clearly?
Yes. Yes, but if you can make them a little bit bigger would be fine. Yes.
So
So
to
the
make them a
scale
bit
there.
bigger, we go ahead and change the scale to 5 and click apply. Ooh. Once again, the apply button isn't accessible to me, so apply and OK.
That's great.
So there we go. The other data set that we will need for this is the pit design. And just to make things interesting, we're going to chuck in, I don't know, something. As an engineer, you probably want to drill to the top of that surface over there. Let me just zoom out. Let's give ourselves some logical reason as to why you would only want to drill to the top of that thing and blast only that material, but we're doing this for the sake of this example. So in case you're wondering why your colors are suspended, that's because they were surveyed on this topography over here. So let me just make this a bit transparent by double clicking it and saying, okay, I think. Yeah, good. I couldn't see the OK button over there, so we're good now. So you can see that we've got this very hard-working surveyor. So in this case, I'm going to claim these that went ahead and surveyed the whole colors for this bench. And then we want to have an estimate of the volume of yield that we're going to get from that specific area. But the engineer subtracted indicate from the drill pattern indicated that this should only be drilled to that surface, so the drill depth was probably adjusted to suit. So let's unload the topo so that we're able to see things a bit more clearly. So we've got that as the pit design, and then we've got our whole colors, and then we've got that thing. So this thing, for some of you that are dealing with the coal mines, this might be your coal seam that you're mining. So generally speaking, in as far as coal mining is concerned, you don't really want to drill into the coal seam from waste. So you want to just stop short of where that coal begins. And this would be an example of how this blast volume is going to be dealt with. So let's just switch off these two DTM so that what we're looking at is our colors. And since these are already sorted, we can go ahead and say, add to database. We want to add a designed pit surface, and it's going to affect our current pit, same area. This was done by Haja, she's the mine design engineer, and we add that. task completed successfully. We can add this as a pit blast bottom. So what this is we're only going to blast to the surface of that pit, and this applies only to the current pit. Reference name, we'll call this BL at 1040. We can add that to the database, and we're cool. So those are two data sets that we need. And just for the sake of it, we can also add the surveyed pit surfaces for those that missed last week's session. We can add the topo as well to our database, and that was surveyed by Haja. So she probably went in with a GPS and picked up the entire pit over a weekend and came back. So there we go. So coming back to the calculation of our blast volumes, what we're going to do first of all is define a perimeter. Okay, so to do that, we go to our edit tab, and in this case, I'm going to switch on the auto node, and then new polygon, and py, or new string, that's entirely up to you. And you can see how much of a breeze it is to digitize around points in Studio Survey. This is just one of the things I enjoy doing. You know, it's going to be tedious doing this any other way. So we have ourselves a outline. So once we've got this set up, we then go back to our reports and click blast. So before I continue, I must mention that the blast volume calculator is going to be different from these typical reports that you run at the end of your reporting period. So if you're reporting at the end of the month or at the end of a quarter, you're going to have these reports generated in that session. Whereas for this can be more your day-to-day or every second or every third day whenever you pick up the whole collars in your pit. So in this case, we've picked up the whole collars that define a perimeter. Now, I'll admit, if this doesn't look like what you're used to, it's because it was drawn by me, and I am not a professional mining engineer. I am a surveyor. So Haja, I'm going to blame you for this blast design if it looks in any way unrealistic.
Okay.
So here we go. So we go to our reports and click blast. So we get that dialog box. The other way to do this is to type CBV. So as a surveyor, you would go ahead and once they've drilled out whatever blast design was drawn, you're going to go pick up each individual hole and then define a perimeter like we did just now. And in this case, we know, depending on how you define your blast IDs. So for this one, we're drilling from 1050 bench going to 1040. And since it's my pit, I'm going to say I'm going to drill this from 1050, and that will be my naming convention from now onwards. We shall always name these blasts from the top. And if you disagree with me and you say, yeah, no, but we always name them by the toe, then you'd name it 1040. But different mines have different conventions, and it's entirely up to you how you go about that. So I'll name it 1050 and continue. So the first thing that we're going to do here is define our blast outline. So in this case, we've got this new string here, and we select the string that we're going to use as a basis for defining our blast outline. So we're going to use this same perimeter of the blast holes that we picked up and say get outline. So the moment we get outline, Studio Survey immediately creates for you another object in the file, which is called the blast boundary. So what that does is it leaves your original string intact and makes it so that when you run your adjustments, say in this case, we're going to expand. We're expanding by 2.5 because we know that our blast burden is 5 meters. So that goes all the way that side. Ooh, something funny happened there. So we can just delete that point, DPO, fixed, and we're good to go. So we have a blast outline as defined by the extent which we expect the hole to have influence. So very quickly, I'm going to load back our anomaly that we've got and the pit design as well. So the reason for this is I want you to see the various data sets that the blast volume calculator is going to honor. So we've got this anomaly that was identified, or the seam, the top of the core seam that you don't want to drill beyond, or maybe it's a pocket of emeralds and that's just what you want to expose at that specific point, and you want to blast here and then go down. So you definitely make such adjustments for that specific bench, and then you can also make an estimate on what the trend is from that point onwards. So at that point, we've gone ahead and defined our blast outline, and we need to get our top surface. So in this case, our top surface, we'll use the color points. Since the surveyor went out into the sun, picked these XYZ, 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 it's bound to give us an accurate representation of the topography of that area. So once that's taken care of in terms of our top surface, we then choose the various parameters. So we're going to do this calculation twice. First, with the blast RL being 1040, which is where we're blasting to. So this bench over here has an elevation of 1040. And then we're going to also say, you know what, recognize this anomaly. So the anomaly that we're recognizing is that one. We want the blast to be calculated up to that point, and because the drill design was issued to that effect, we load that in as well. Also, we want to make sure that we are honoring the pit design. So all of these holes in the perimeter at the back would have been probably drilled to very short lengths or inclined and so on, but in such a manner that they honor the pit design. And we go calculate. And our task is completed. So what we have now is that blast volume that has been calculated. So let's just zoom out a bit. Let's pack that away. Let me change, let me just hide this. Okay. So as we examine our blast volume, what you're going to see is it honored the extent of the pit. Okay. So this went as far as the pit design, and also our calculation also honored that anomaly that was in there. So all of our holes that were drilled that were indicated to only go that far, we can see that it honored that thing that was there. I don't have a very good name for it. Sorry, I should have spent some creative time thinking about what to call it. So all of those reasons could exist. So we have definitely gone ahead and done a calculation for your blast volume. So let's bring up the calculator back. So what you have here is a situation where that blast bottom is being honored. So if you choose not to, let's change that. Let's call that blast number 2 and calculate. Boom, done successfully, and we can load that data set in by clicking the arrow. You'll see that it has now disregarded that anomaly that was there simply because we have said we do not need to use that anomaly in our computation. So you can constrain this also by elevation or by pit or by elevation. So let's say we want to calculate this up to a height of 1045 and within the constraints of the pit design. When you calculate that, oops, sorry, my bad. We haven't changed the blast ID. Yes. So we change our blast ID to blast number 3. So what we're going to have here is 3 different blasts that we're going to compare against, and you calculate that. Perhaps you're making an assessment to say, you know what, maybe it might be easier for us to blast this in flitches. So we have, oh, I didn't load that last volume, eh? So 1045, calculate, yes, that's there, +3, nope, and then we load. Load it. Okay, we're good to go. So we come back to our sheets and we have the third wireframe, which you can see has been constrained by the elevation that we changed here to 1045 from the original 1050. So that will be another quick way of performing that blast calculation. So there you go. That is the Studio Survey blast volume calculator with the 3 types of outputs that you can get out of it. So the next thing that you're going to do, now that you've got your blast volumes calculated, you can then go back to your reports and publish. So today we've done our stockpiles and we've done our blasts, but just for today. And we go ahead and publish. Publish, publish, publish. Okay. So once you've done your publication, you can go ahead and view your results by clicking the oogly eye. I don't know what it's actually called. So you have yourselves the individual blast volumes. So I'll find out. Don't worry, I'll find out. So you've got your first blast volume, which took stock of that anomaly. You've got your second one and third one. Now, obviously, these blast volumes will be for different areas. If you're looking at it in practical terms, you might have a blast volume for what we're looking at now, which we've done 3 times, or you can have another area here and so on. And Studio Survey will keep a database of these volumes for you. So each of these volumes will be reported. And then in the same report, you're going to have the same stockpile values that we calculated published. And if you had done a compliance to design, you would have that report there. If you had done a compliance to plan, you would have that report there. If you had pit mined volumes for the month, you would have that report there. And if you had, and at the end of the day, your first page of your process is a summary that tells you what your mined volumes are, what your stockpile volumes are, and what your blast volumes are. Now, this is incorrect because we've got 3 successive blast volumes over the same area. So be careful not to do this. Make sure you've only got 1 blast volume for 1 specific spatial location in your pit. And you're going to have yourself a nice, consistent report. This was done specifically for the sake of the example that we needed to do. So in here, the correct volume would then be 24,842. So at this point, we have 7 minutes towards the end of our demo. We're going to unmute and open up our session for questions. Do we have questions? Does anyone have a hand up? No.
No.
Oh, there's a hand. Nikki. Okay, Nikki, it's that comment that you made. I'm not sure if that's a question that Aaron has. Aaron, is that a question? You're live.
Hi, Kaluba.
Hey.
Just wanted to know, I know that you've spoken that on the first webinars, but if you can say again about the compatibility with the total stations, GPS, drones, how it is easy to import data from these devices.
Okay, excellent. So since we've got Studio open, thanks for that question, Aaron. On the Home tab, one thing that we did mention in the previous webinars is that this is arranged in the same manner that you do your work, from left to right, kind of reading. English, French, and most other languages except Chinese and Arabic, Haja, where you read from this side going that way. Yeah, so in this case, we're going to go through the workflow in the same manner that we are going to read. So the first thing that you're going to do is import your survey data using the survey import tool. Again, it's opened over to the side. So let me just close that and click it open so that you can see how quickly, oh, it still wants to open on my other screen. So that's fine.
Must be happy.
So what you've got, it doesn't want to listen. It's going to have a hiding after this. So you've got these options of equipment that have been made compatible to the software. You simply plug your GPS or total station into your computer and you'll be able to process jobs in that manner. You'll be able to save, like in this case, you'll be able to deal with a Leica dataset, a DBX, a GSI, or a field file. This would be an internal format that you've customized for yourself. It's going to handle a DBX file from a Leica GPS or from a Leica total station. So you just select which one it is, as well as the respective GPS heights that you've got. So it might be orthometric or ellipsoidal. And then your various processing methods. And then you are going to choose which surveyor did this job. And once you do that, you simply browse over to the location of your job and you're good to go. You import that, and once you import your job, that importer creates a DM file that you will be able to view immediately in Studio Survey. Does that answer your question, Mr. Muniz? We've muted him. Anybody else with a question? Nikki Herrero. Hi,
No
Nikki.
questions. Hi. Very nice presentation. I have no questions right now.
Oh, okay, cool. So I
Just
think,
one quick one.
Yep. Yes, Haja.
So for the videos for the first and the second webinar, I've checked with our marketing department. They are just doing some requirements for the intro and the outro. So it will be ready on YouTube very soon, but we can put them on a OneDrive and send it via email after this webinar. Is that okay?
Yep, cool. There's someone here that I would like, there's another question coming down. Is that a question? We have some written questions. So we got this design from Data Blast, which is our open pit blasting management tool. I think maybe, let me just have someone say a few wise words about Data Blast. I am unmuting you, sir.
Thank you, Kalamba. It's interesting to see. I was very glad to see you showing this pattern in survey because it's helpful to show how data mine products integrate between themselves. So it's interesting to see this. It's a raw file, but it was generated in Data Blast or Driven Blast management solution, which can be synchronized with several other platforms like Studio Survey. And all the calculations, all the volumes, and all the information that you generate in any platform can be sent across all the range of products. It's very nice to see that.
All right. Thank you very much. Edward, do you have any questions? At least
No
I know you've
questions, but thanks. No, I've been following everything. I'm fine for now.
All right, thank you. Okay, so I think at this point we have come to the end of our webinar. Thank you very much for attending and thank you very much for your time. Haja, do you have a word?
No, just one question, but it's fine. We can send an email after it.
Maybe somebody else has the question or might benefit from it.
Okay, so Nikki, he's asking about is the anomaly can be a preparation for a ramp?
Yes, that's actually a very, very good one. Thank you for that one, Nikki. I was really struggling to come up with a name for that. I just wanted to show that we can actually do that. Thank you very, very much for that. So yes, that anomaly can be preparation for a ramp. Agreed, 100%. So I think that's a pretty decent end to this webinar. Thank you for coming.
Thank you, everyone.